Hi friends, we'll solve problem on variable acceleration. You see what is given in problem. Acceleration of a particle is directly proportional to the square of time t. When t equal to 0, particle is at 24 meters. Knowing that at t equal to 6 seconds, x equal to 96 meters and v equal to 18 meters per second. Find expression of x and v in terms of time t. Also find velocity and position at t equal to 2 seconds. Now here a relation is not given, a relation is given in wordings. Acceleration of particle is directly proportional to the square of time t. That means in equation form, if you want to write, can you write this one? Acceleration a is directly proportional to the square of time t, that means directly proportional to t square, you can say. Now therefore from this one, a if you want to write, you will get constant of proportionality. Say constant of proportionality is k t square, equation number 1. That means a is a function of time t. What is asked in problem? Find expression of x and v in terms of t. That means acceleration a as a function of time t can be written in terms of velocity and time t. We will get equation of velocity in terms of time t. A is a function of time t. A will write in terms of time t as what? dv by dt. dv by dt equal to kt square. If we will multiply here by dt on right hand side, so it becomes kt square dt. Now if we integrate this equation, we will get integral of dv equal to integral of kt square dt. Now if we integrate, what we will get here? Integral of dv becomes velocity v. K is a constant, therefore what we will get here? K into t cube by 3 and constant of integration, say c1, equation number 2. That means what you are getting here? Equation of velocity in terms of time t. But as unknowns are 2, k and c1, direct solution is not possible, because using single equation, and what condition you know at t equal to 0, particle is at 24 meters. That means this one condition is for position and not for velocity. For velocity, what condition is known is at t equal to 6 seconds, x is 96 and v is 18. That means velocity 18 meter per second at 6 seconds. If we use t as 6 seconds and v as 18, v 18 and t 6, what is possible here? Direct solution is not possible. What will get? Relation between k and c1 is possible. Therefore we will use this condition and we will substitute, so that we will get one more relation between k and c1. Therefore what condition is given? At t equal to 6 seconds, velocity equal to 18 meters per second. Now if we substitute this time and velocity in equation number 2, what we will get here? Velocity is 18 equal to k into t cube by 3, that means 6 cube divided by 3 plus c1. That means what you are getting here? Relation between k and c1. So if you solve this one, 6 cube divided by 3 comes out to be 72. Therefore this equation becomes 18 equal to 72k plus c1. Say this one is equation number 3. That means direct you can say c1 is not possible. Therefore what you know? Equation of velocity v equal to k into t cube by 3 plus c1. This is the relation. That means v is a function of time t. If we substitute v as a dx by dt, rate of change of displacement with respect to time, so what will get here? V in terms of t, that means again integration is possible. We will get relation between x and t is possible. Therefore v equal to dx by dt equal to k into t cube by 3 plus c1. That means dx equal to k into t cube by 3 plus c1 dt. If we integrate this equation, we will get integral of dx equal to integral of k t cube by 3 plus c1 dt. Now if we will integrate it, we will get one more constant of integration is possible. Therefore, if we integrate, integral of dx is x, integral of t cube by 3 becomes t raised to 4 upon 3 into 4, that means what, 12, right? 3 into 4 plus this one becomes c1t, and one more constant of integration is what, c2. Say this one is equation number 4. That means you are getting relation between c1, c2 and k. One more relation what is available is relation between k and c1. Now anyhow, using this equation of x as well as equation number 3, you have to find out c1 and k. For that one, what condition is given in problem? This position is given at some different time instances. What is given? Initially when t is 0. See here, what is given? At t equal to 0, initial boundary condition, when time t equal to 0 second, x is given as 24 meters. Now as t equal to 0, x is 24 meters, you know relation between x and t, which is nothing but equation number 4. Now in equation number 4, if you substitute, put x equal to 24 meters at t equal to 0 second, will substitute in equation of position. Equation of position is equation number 4. Therefore, what will get here? X, equation number 4, what we are getting is k t raised to 4 upon 3 into 4 is what, 12, plus c1t plus c2. If we will substitute x equal to 24 equal to, now this k into, now t equal to 0, that means this term becomes 0, plus again this one is 0, plus this one is c2, that means we will get value of c2. c2 equal to, if we find out, this one is 24 meters. That means c2 you will get substituting initial boundary condition. One more relation or one more data is known at some time instant, what is the position. One more data what is given at t equal to some 6 second, some different position, that is 96 meter is given. That means at this condition I will write here first one, t equal to 6 second, what position is given is 96 meters. This one x and t value, again we will substitute in equation number 4. Now what will get here? X is 96 and t is 6 second, therefore k into 6 raised to 4 upon 12 plus time t is 6, that means 6 c1, and c2 already you have calculated, this is what, 24. Solving this one, again c1 and k directly not possible, but you will get some relation between k and c. If we will solve, we will find out what is the value. So 6 c1, then what you will get here, 24, 6 raised to 4 upon this 12 will get some value, and using this one, see 6 raised to 4 upon 12 is 6 c1 and 24. From this one, if we will find out these values, this one value comes out to be 72 equal to 108k plus 6 c1. That means this is 96 minus 24, if we will take, we will get what, 72. Say this is equation number, see here up to 4 you are written, say equation number 5, what you are getting, this is equation number 6. Equation number 6 is relation between k and c1. Similarly, one more relation between k and c1 is equation number 3. Therefore, if we solve equation number 3 and 6, solving equations 3 and 6, what will get here? K is possible as well as c1 is possible. If we calculate, k comes out to be 1 by 9 and c1 comes out to be what? 10. K is known and C1 is known. If we substitute K and C1 in equation of velocity, what we'll get here? Equation of velocity means what we have written, that is V equal to K is 1 by 9, C1 is a 10. We'll substitute this value of K and C1 in equation of velocity. Therefore, equation of velocity becomes V equal to T cube divided by 27 plus 10. This is equation number 7. One more relation, that is equation of position in terms of time t. For that one, again we will substitute K and C1 in equation number 5. If we will substitute in equation number 5, what equation we will get here is from equation number 5, equation of position. This one comes out to be x equal to 1 by 9 into t raised to 4 upon 12 plus, let me simply substituting value of K and C1. Next part what we will get here, this is a 10t plus 24. From this one, equation of x comes out to be t raised to 4 upon 108, that is 12 into 9 plus 10t plus 24. See, this is next equation, equation number 8. That means equation number 7 and equation number 8 represents your answer, because you have to find out relation between velocity and time and equation of position in terms of time t. That means equation number 7 and 8 are answers. Now you have to find out some velocity and position at t equal to 2 seconds. Therefore, if we substitute t equal to 2 seconds in which equation? Equation of velocity and equation of position, you will get velocity and position at t equal to 2 seconds. If you substitute in equation number 7, what will get here? Velocity. I'll write with suffix 2, which represents what? At time instant 2 seconds, equal to 2 cube divided by 27 plus 10. That means velocity what will get is 10.296 meters per second. This is your answer at 2 seconds. What is the position? Velocity. And in equation number 8, if you substitute, what will get here? Again position at 2 seconds, where equation is t raised to 4 upon 108. That means here if you substitute t equal to 2 seconds, 2 raised to 4 upon 108 plus what will get here? 10 into 2 plus 24. That means what position will get at 2 seconds is 44.148 meters. This is your next answer. Thank you.